When we pause to review history, we are given the opportunity to look back and learn from the actions of the people who have gone before us. We glean lessons from the pages of history that can help us understand what brought us where we are today and help us plan for tomorrow. You are standing in a building that is a birthplace for modern manufacturing. The ripple effect of what happened within these walls can be felt around the world in significant ways. The lessons learned here affected so many things. The way we made, sold, and transported goods, or the food that we had grown. The innovations from this building determined our nation's ability to arm itself as we sought to defend our freedom. The race to reach the moon, the phenomenon of Silicon Valley and the personal computer and the handheld devices we use now. Let's look back and face forward as we explore the evolution and the innovation of technology and careers. The story of American Precision Museum, originally the Robbins and Lawrence Armory, begins with its strategic placement and close proximity to the river. Pioneers in green thinking, the early inventors knew that to innovate, they would need to harness the power of the water to drive their inventions. By diverting some of the water to run under the building, they could let the water propel a giant water wheel that would drive belts that would power the machines that were being invented. The machine tools invented here would not only shape the metal and the wood, but they would shape the course of history. In 1818, Thomas Blanchard built an invention that transferred a shape from one object to a new piece of raw material. This copy lathe duplicated complex wood shapes from gun stocks, axe handles, wheel spokes, and more. This invention ushered in a critical understanding. Duplication was essential for mass manufacturing. By 1846, the U.S. Army asked Henry Stone, Richard Lawrence, and Frederick Howe to fulfill a contract to make 10,000 rifles with interchangeable parts. They not only innovated mechanics, but also the systems and processes, with workers and machines specializing in specific tasks and operations. They proceeded in 1851 to exhibit their rifles at the Crystal Palace exhibition in London, leaving the British speechless as they disassembled several guns and then reassembled them while interchanging parts. This revolutionary new method ultimately became known as the American system of manufacturing and became the basis for all new types of manufacturing. From this moment on, the pace of progress accelerated. Understanding the value of interchangeable parts opened a floodgate of innovation, allowing machines to be made in large quantities and sold at more affordable prices. The 1850s through to the 1920s saw the mass manufacturing of what would become common household items: sewing machines, typewriters, bicycles. Manufacturing of well-made yet affordable consumer goods improved the quality of life for everyone. With the rise of mass manufacturing came the rise of labor-saving inventions. The sewing machine saved women in the household countless hours of hand-stitching with needle and thread and revolutionized the textile industry. Agriculture was radically transformed. The iron plow with the interchangeable parts was invented in 1819. Producing 100 bushels of wheat took 250 to 300 labor hours. By the 1930s, it was only 15 to 20 labor hours. This dramatic reduction was due to the invention of the internal combustion engine in the 1870s. The shift to horseless farming increased productivity and made the difficult work of farming more efficient. Infrastructure was dramatically altered as trains and railway systems were developed. By the 1890s, railroads supplied cities and towns with food, fuel, building materials, and access to markets. Mass manufacturing of combustion engines led to the invention and rapid growth of the automobile industry in the early 1900s. With these methods of transportation came freedom. The freedom to travel farther, faster, and to do it independently. It was a manufacturing revolution that altered reality for every American. To this day, precision machine tools continue to make the mechanical equipment of our modern world. In the late 19th century, it was like new and completely revolutionary. Like Silicon Valley in the 1970s with Steve Jobs and other young inventors working out of their California garages and changing the world in the process, Precision Valley was game-changing. Windsor County, Vermont was where young apprentices in the 1850s, 60s, and 70s went to launch careers as machine tool builders. They became entrepreneurs, and the companies that grew out of this formed the area known as Precision Valley. It was the Silicon Valley of the 19th century. Their machines were at the center of new technology. They would play a pivotal role as the world barreled towards brutal conflict, World War. As the world went to war, there were exponential leaps in innovation. The skills and experience of the innovators were transferred from mentor to new inventor. We saw tanks, bombs, and planes develop from the understanding that the leader in technology would ultimately win the war. When the guns were finally put down and the conflicts were settled, wartime machines returned to the manufacturing of typewriters and radios, bicycles, and cars. Factories retool to meet the fast and growing hunger for consumer products. Technology and science were embraced by the masses, and new innovations bred new inventors. New machines called computers were put to work, ushering in a new age, the dawn of the digital era. The human mind and the power of the processor were now building what once seemed impossible. The rise of automatically programmed tools, CNC controls, robotics, and the ever-growing capabilities in machine tools opened a new chapter for innovation. American ingenuity gave the general public the power to take an idea from their head and mass-produce the result, empowering inventors and creators to take their ideas and touch the lives of other people. The young man that seeks to find himself can, in high school, build a car that will race across the country, sparking in him a dream to one day own his own shop. The girl who always loved to stare at the stars, dreaming of touching the far reaches of space, is able to engage with NASA and their Hunch program, building flight hardware that will go to the International Space Station. The team of high school students who learned about the devastating effects of a stroke use the combined power of 3D modeling and additive manufacturing and go on to design and build a device that will aid in the trauma victim's recovery. It's the rise of the machine controlled by the human. Unthinkable forces are now under the control of the hand and the mind, allowing a human with new skills in a new world to achieve things that were unthinkable only a few decades ago. As you walk around the museum, look and listen. Stop and think about the inventions and the innovation. We are standing on the shoulders of giants. But this isn't just about history. Don't get stuck in the past. Think about the fact that we used to build cars almost entirely by hand, and now our hands are used to program robots that do the repetitive and more dangerous aspects of the job. Advanced manufacturing innovations are allowing us to harness the power of wind, water, and of the sun. Consider the potential of a whole new generation of inventors who are hungry to safeguard our natural resources as they dream about the things that their hands and their minds will invent. The inventions here don't simply remind us of a bygone era. They show us who we can be. The humans who invented these machines were problem solvers, marked by hard work, passion, and creativity. They made their mark on history and have laid a foundation upon which we can build. Listen closely. and you will hear the whispers of the men and the women who have gone before us. What will you do to shape the future?